Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to look at the properties or rules of logarithms. So remember that a logarithm is just an exponent. So think about the rules of exponents. For instance, if we have x cubed times x to the fourth power, this is just x, 1, 2, 3, 4. Notice that we have a total of 7 of them, or our exponent rules tell us that we just add those exponents to get to x to the 7th power. Well, with logarithms, we have a similar property or rule, that when we have some log base b, and inside our argument, we're multiplying two numbers together, that's equal to the log base b of your first number plus the log base b of your second number. So it's really similar. For instance, if I have log of 1,000, we know from evaluating logs that we have an understood base 10 here, and we're asking 10 to what power gives us 1,000. Well, 10 times 10 is 100, times another 10 is 1,000, so it's 10 to the third power. This is just equal to that exponent of 3. 10 to the third power equals 1,000. I can rewrite this as a product. This is equal to 10 times 100. And then I can use my product rule to, and I will get the same answer. So here I have log base 10 of 10 plus log base 10 of 100. And 10 to the first power gives me 10, so this is just equal to 1. And 10 to the second power gives me 100, so this is just equal to 2. And notice I end up with the same answer. So the product rule says that when in my argument I have the product of two numbers, that's equal to the sum of their logs. Now, let's look at the quotient rule with exponents. So if I have something like z to the 6th over z to the 4th, that's 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. Notice I'm left with z squared. Or we know from our quotient rule with exponents that we can just subtract our exponents to end up with that z squared. There's a similar property or rule with logarithms, that when in my argument I have a quotient, I have something dividing in my argument, that's going to be equal to the difference between the two. I can take my top number, the log of my top number, the numerator, and subtract the log of that denominator. So, for instance, let's say that I have log of 1,000 divided by 10. Well, first, if we just look at 1,000 divided by 10, that's just equal to the log of 100, which is 10 raised to the second power gives me 100. Or I could use the quotient rule there so that I have 1,000 divided by 10. Well, that's log of my numerator minus log of my denominator. So 10 to the third power gives me 1,000. 10 to the first power gives me 10. So I end up with 2 again. So that's the quotient rule, that when I have something dividing in my argument, it's equal to the difference of their logs. And then the last one that we're going to look at is the power rule. So remember with exponents that when I have something raised to a power, so that's y to the 5th times y to the 5th, so that I really end up with, back to that rule, where I'm adding them, I end up with 10 of them. Or you can just think of it as my exponents multiplying. So I have y to the 5 times 2, that gives me that 10. That's the power rule of exponents. We have a similar situation with logs, so that I have log base b of some argument raised to a power, and that's going to be equal to this exponent times that exponent. So I have n times log base b of m. So I can multiply those two together. So for instance, let's look at the natural log of e cubed. We saw in a previous video that when their bases are the same, their exponents are the same. Or you're asking yourself, e to what power gives me e cubed? Well, that is equal to 3. We can use our power rule as well, and we can say the natural log of e cubed. Remember, we have understood e as our base. That 3 can be multiplied times this natural log of e, which is the power rule. Well, 3 times e to the first power gives me e, so that's just times 1, is also equal to 3. So there are 3 different rules or properties here that we can use for logarithms. The product rule, that the sum of 2 logs is equal to their product. The difference of 2 logs is equal to the quotient, and then they're in the argument, and here the power can be multiplied. The two exponents there can be multiplied with our power rule. We're going to use these 3 rules or properties to help us expand and condense logarithms. Math made simple at Simpson Math. Thanks for watching.